So in this problem, I've got a bar that's got a changing rectangular cross-section, right? You can kind of see it's a trapezoid then. So for this one, I want to find the elongation of the bar using all those values that I've got there. So my general equation for deflection, okay, is going to be the integral from 0 up to L of p as a function of x dx all over a as a function of x times, e as a function of x. Now, my p is constant, my e is constant on this one, right? It's all the same material. I just have loading at both ends, but my area, my cross-sectional area is definitely changing. So I can bring the two constant things outside. So I have p over a, and then what I'm left with in the integral is dx all over the area as a function of x. And again, this will go from 0 to L. Okay, so let's talk a little bit about what that area is. Well, the area as a function of x is equal to essentially the height, which is b, and that's really what's changing. It's going from 4 inches up to 6 inches. So b is a function of x times times t. So now let's take 2 seconds and figure out what b as a function of x is, right? I've basically got to find the equation for that height b as it moves along the length, right? So it's a straight line, so it's linear. So basically I just need to find the slope of it, okay? Slope is rise over run. Okay, so the rise, right, it going from 4 to 6, so basically rise is 2 inches, right? So I'll just say 6 divided by, or 6 minus 4, right? At one end it's 4, at the other end it's 6, right? So it rises 2. The run is 5 feet, so that's going to be 5 times 12, which is going to be 60, right? Take that times x, right? Because as x, if x is 0, okay, well, when x is 0, the value's got to be 4, right? So that's essentially the kind of the y-intercept, so to speak. So I have to add on the 4. I guess I wasn't done with this, okay? So when x is 0, that first term goes to 0. I'm left with 4. When x is 60, or 5 feet, I'm left with 2 on that left term, and I get 6, right? Because 60 divided by 60 goes away, so then it's just 6 minus 4, which is 2. So it's basically just a linear equation here. Okay, I just find the rise, find that slope, find the y-intercept, or that initial condition of 4, and move on like that. So going back to my area equation up here, now I can go ahead and plug in what I know about the value b as a function of x. Taking things down, it's going to be x divided by 30, just simplifying things, x over 30 plus 4, and then t is 1, as given in the problem statement. T is a value of 1 inch. So, plugging things in now, my deflection is 25,000 pounds, or 25 kips, okay? Divided by E, which is given in the problem statement, is 30 times 10 to the 6 psi. Okay, then my integral from 0 to L, well, I'm going to go 0 to 60. I want everything in pounds and inches, so I go 0 to 60, and then that's going to be God dang it, why is that not? X over 30 plus 4 times 1 all over dx. I will let you do that integral on your own. Okay, and when you do that integral, you do the calculus, you get 0.0101 inches for the elongation. So again, just remember that we do have some changing here, okay? And our most general equation actually takes that into account, and I just have to figure out basically how that area changes as I move down the length. But once I get that, then I can just do the integral and find the answer as shown there.